Morning, everyone. Today's tutorial, I'm going to show you how to evaluate trig functions using what you know about a unit circle and right triangles. So first, let's just review. You probably learned about some of the trigonometric functions in geometry. You probably heard of sine, cosine, and tangent. Well, there's actually 6 trig functions. There's also secant, cosecant, and cotangent, which we're going to be discussing today. Trig functions are just functions that are related to an angle. So we've talked about algebraic functions like a quadratic function or a linear function, an exponential or a log function. When we were in our probability unit, we talked about probability functions like a normal function. And now we're going to be talking about what we call periodic functions or trig functions, trigonometric functions. And we'll get into a little bit more detail about what they actually look like when they're graphed on a coordinate plane in the coming weeks. But right now we just want to make sure that we understand what the operations mean. If I'm talking about the sine or a cosine or tangent, what that means. You probably remember a little bit from geometry. But basically a trig function is just the ratio of two sides of a right triangle given a particular angle. And we can evaluate them using both the unit circle and a right triangle. So let's go back to what you did in geometry, and what we did in the last unit. So we looked at the relationship between the unit circle and the first 3 trig functions, sine, cosine, and tangent, and if theta corresponded to the interior angle and the point xy corresponding to the point on the unit circle. So basically what I mean is, if this is my unit circle, we have our y-axis and our x-axis, and let's just call this angle theta. If I drop an altitude to the x-axis, this becomes a right triangle. And we said basically that the height of my triangle is going to correspond to the y value of this point. So this is the point xy. The x value of that point, or of that point is going to correspond to the adjacent side of my triangle. So in geometry, you probably, that was called theta, and then we had the sign opposite theta. We had the side that was adjacent or next to theta, and then we had our hypotenuse. And all we're doing is basically taking this triangle and putting it in a unit circle. When we do that, remember, because it's called a unit circle, our hypotenuse just has a length of 1. And so if you think about SOHCAHTOA, we know that cosine, let's just review. There's SOHCAHTOA. And so with the cosine, I know that means that it's the adjacent side over my hypotenuse. And that's from geometry. If we relate it to the unit circle, that means I'm dealing with x over 1, because x is my adjacent side and my hypotenuse has a length of 1. So that just reduces to x. With the sine, it's going to be opposite over hypotenuse, and that's just going to reduce to y over 1, or simply y. And then our tangent, TOA, is opposite over adjacent, and our opposite side again is y, our adjacent side is x. So it's just that ratio when we're looking at points on the unit circle. And I'm literally taking the x coordinate or the y coordinate of the point and manipulating it. The other 3 functions are what we call the reciprocal functions. And if you remember, reciprocal is essentially when you flip a fraction. Okay, and so the secant, and this is where it gets a little confusing, the secant is actually the function that corresponds to the cosine, and it's actually equivalent to 1 over cosine of theta. Well, cosine of theta, remember we said, is just x, so that's going to be equivalent to 1 over our x value. Since most of the x values in our unit circle, though, are fractions, it might be easier to think of this as simply flipping the x value. The cosecant actually corresponds to the sine function. It's just the reciprocal of the sine function, 1 over sine or 1 over y. And since a lot of the y coordinates are also fractions, it's easier sometimes just to think of this as flipping the y value. And so I think it's illogical the way these functions are named, because you would think that cosine would go with cosecant, but it doesn't. Cosine goes with secant and sine goes with cosecant. So it's a little illogical in terms of the way that they're named. With the cotangent, this is the same as 1 over the tangent of theta. And 1 over the tangent of theta is just going to be the reciprocal. So in this case, it's going to be x. Well, it would be the same thing as this time the cosine of theta over the sine of theta. And notice that anytime I'm writing sine, cosine, or tangent, I'm always including the angle measure. Remember, they are functions. So like when you're dealing with algebraic functions, we're used to saying f of x, or f of 2, or f of 6. You would never just write f. You have to evaluate the function for some value. And a cosine, sine, tangent is just the name of the function, like f. So you want to make sure that you're always taking the cosine of something or the sine of something. So you always want to include the angle measure. And so another way of thinking of this then would be x over y, or simply flipping the tangent of theta. Okay, and so I'll show you what I mean by this when we start looking at an example. I'm actually going to come back to the unit circle in just a second, but let's think about the angle where theta is equal to pi over 6. What we want to do is find the coordinate, or find the ordered pair on the unit circle that corresponds to an arc length of pi over 6. So pi over 6 is this arc length right here, is this angle. This would be what theta represents. And so what I want to do is just identify the x and the y values of that coordinate. So I'm just going to write them here, the square root of 3 over 2 and 1/2. And remember, this is just an x value and this is just a y value. So if I want to evaluate the cosine of theta, this is the same thing as me asking, well, what is the cosine of pi over 6? Well, if we go back, we said that the cosine is simply the x value of that point. So the cosine of pi over 6 is simply the square root of 3 over 2. That's pretty straightforward. The sine of pi over 6 is just going to correspond to the y value, and the y value of this coordinate is just, or of this ordered pair, is just 1/2. The tangent, now this is where you have to do a little bit of math. The tangent, we said, is going to be y over x. So if I think about that, it's going to be 1/2 divided by the square root of 3 over 2. And this may look a little funny to you. This is what we call a compound fraction, where I'm basically dividing two fractions. But you learned how to do this in elementary school. If you remember, dividing fractions is the same as multiplying by the reciprocal. So that means that the top fraction is going to stay the same. It's going to be 1/2, but instead of using division, I'm going to change it to multiplication. And then I need to multiply by the reciprocal of square root of 3 over 2. And remember, reciprocal just means flip. So I'm going to be multiplying by 2 over the square root of 3. When we're multiplying fractions, you can do one of two things. You can simplify. Anything in the numerator can cancel anything in the denominator if they have common factors. So for example, I've got a factor of 2 on top and a factor of 2 on the bottom. I know those two values are going to cancel. Another way that you can do is just go ahead and multiply across the top, multiply across the bottom, and then reduce your fraction. I think it's easier to cancel first because then there's less to multiply. Remember that, again, we're multiplying across the top, so I've got 1 times 1 is still just 1. And then in the denominator, I'm left with the square root of 3. Now, fractions have a lot of rules that apply to them. Just like in English, you have to deal with grammar. And when we're dealing with fractions, we're not allowed to have decimals in our fractions. We're not allowed to have imaginary numbers in our denominator. We're also not allowed to have square roots in our denominator, or any root for that matter. And so we have to do what we call rationalizing the denominator, because the square root of 3 is in fact an irrational number, meaning that I can't rewrite it as a fraction. And so to fix it, I don't want to change the value of my fractions. So the only thing I can multiply by is 1. But I'm not going to multiply by the number 1. What I'm going to do is I'm going to think about how I can get the square root of 3 and make it into a whole number. And what I can do is simply multiply by another square root of 3. Because when I do that, I get the square root of 9. And the square root of 9 is just 3. So if I multiply a square root by itself, it becomes a whole number. But I can't just do that to the denominator of the fraction, because then I'm changing the value of the fraction and I'm not allowed to do that. Remember, I said you're only allowed to multiply by 1. So I need to somehow make the second number into a fraction that's equivalent to 1. And I do that by multiplying the top by the square root of 3 as well. And so this quantity now is just equivalent to 1. It just doesn't look like that. And when I multiply across the top, then I'm going to have 1 times the square root of 3, which is simply the square root of 3. And so even though I know it actually doesn't look any more simple than the other one does, that is the proper way to write the fraction. When we're dealing with secant, we said this is the same thing as flipping x. So the secant of pi over 6 is going to be what happens when I flip x. And so to do that, I get 2 over the square root of 3. Well, again, I run into the same problem that I had before. I'm not allowed to have the square root of 3 in the denominator. So I'm going to multiply the top and the bottom by the square root of 3. So on the top, I'm going to have 2 times the square root of 3. And on the bottom, remember, that's the square root of 9, and the square root of 9 is just 3. And so you're going to want to do that every single time you're dealing with fractions if you end up with a radical in the denominator. The cosecant, we said, is just the flip of the sign or the flip of the y value. In this case, that would become 2 over 1, and 2 over 1 is just 2. So that was easy. The cotangent is the same thing as taking x over y, or you can also look at it as flipping the tangent. Well, if I go back to the original value that I had for tangent, that 1 over the square root of 3, I can flip it at that point, and then I end up with the square root of 3 over 1. And, dividing by 1 doesn't change anything, so I ultimately am left with the square root of 3. Now, if you forget that, we can just go ahead and do x over y. X over y would be the square root of 3 over 2 divided by 1/2. And remember, when I'm dividing fractions, the first number stays the same, and then I change it to multiplication, and I flip the second fraction. My 2's end up canceling, and that will leave me with the square root of 3. And as long as it's at the top, as long as it's in the numerator, you're good to go. You can leave your answer that way. Let's take a look at another example. This time we're looking at theta is equal to negative pi over 4. Well, we got to be careful with that negative because that's pretty much telling us to go in a different direction. So here's pi over 4. This is a positive pi over 4. If I want to go a negative pi over 4, I'm going to go the same distance, but I'm going to be going in the opposite direction. I'm going to be going clockwise. And so the ordered pair associated with that angle is going to be the square root of 2 over 2 and negative square root of 2 over 2. So I'm going to write that down. And remember, this is my x value, this is my y value. So the cosine just corresponds to my x value, and that's just going to be the square root of 2 over 2. The sine corresponds to y, so that's just going to be the negative square root of 2 over 2. Tangent is y over x, and so it's going to be negative square root of 2 over 2 divided by a positive square root of 2 over 2. Well, take a look at these two fractions. They're the same, essentially. I mean, the sign's different. I know if I take a negative number and divide it by a positive number, my answer should be negative. And since both of those fractions are the same, anytime you divide a number by itself, you just get 1. Now, if you don't see that, you can actually go ahead and do the multiplication. The first fraction stays the same. Let me do it up here so I have a little bit more space. And then I want to multiply by the reciprocal, so I flip the bottom fraction. My 2's are going to cancel, and my square root of 2's are also going to cancel, because anything divided by itself is just 1. And since one of the fractions is negative, I know my answer is going to be negative 1. The secant, remember, it's going to correspond to the cosine, and it's when we flip it. So this is going to become 2 over the square root of 2. But now I have a problem because I'm not allowed to have the square root in the denominator. So this time I'm going to multiply both the top and the bottom by the square root of 2 over the square root of 2. So on the top, I'm going to have 2 times the square root of 2. And on the bottom, this is going to become the square root of 4, and the square root of 4 is just 2. Now I do want to continue reducing my fraction if I can. Notice that I have a whole 2 and another whole 2. I have a whole 2 on top and a whole 2 on the bottom. Those are going to reduce to 1, and so my final answer is simply the square root of 2. The cosecant is just going to be the flip of the y. So that's just going to be 2 over a negative square root of 2. Well, that's essentially what I did in the last problem, except my answer's got to be negative. I'm not going to do the math all over again when I've already done it. And the cotangent is just going to be the reciprocal of the tangent. Well, if I take the reciprocal of negative 1, it's still negative 1. So sometimes things look a little bit more complicated than they really are. And you don't actually have to go through all of the calculations if you've already sort of done them in a previous problem. Okay, so now we're looking at an angle that is measured in degrees. So I'm going to find 150 degrees on my unit circle. Let's go back to my unit circle. 150 degrees is this angle right here. And so the coordinates associated with that are going to be negative square root of 3 over 2 and 1/2. Okay, this is my x, this is my y. Okay, so I'm going to go through this pretty quickly. The cosine, again, just corresponds to the x value. cosine corresponds to the y value. The tangent is going to be y over x, which is just going to be 1/2 times the reciprocal, so -2 over the square root of 3. My 2's are going to cancel, so I'm going to be left with -1 over the square root of 3. And we said to rationalize that, I'm going to multiply both the top and the bottom by the square root of 3. So I'm going to have negative square root of 3 over 3. The secant is what I get when I flip the cosine, so that's going to be -2 over the square root of 3. Again, I'm going to multiply the top and the bottom by the square root of 3. -2 times the square root of 3 over 3. The cosecant is what I get when I flip y, so that's just going to be 2. And the cotangent is going to be what I get when I flip the tangent. Well, I'm going to go back to what I had originally for my tangent, and it's going to be the square root of 3 over -1. Now, it doesn't matter where the negative is. This is the same thing as negative square root of 3 over 1 or negative square root of 3 over 1. Since I'm dividing by 1, my final answer is simply negative square root of 3. Okay. All right, so in example 4, it says, what points on the unit circle correspond to a reference angle of 30 degrees? What we mean by reference angle is basically we're always coming back to quadrant 1. But there's actually 4 different points that correspond to that angle. If you think about a 30-degree angle, this is a 30-degree angle right here. And if I think about my unit circle, I know the coordinates for this point are going to be square root of 3 over 2 and 1/2. Well, what we mean by reference angle is that there are points, there's a point in the second quadrant that also maps this same angle. And the coordinates would be negative square root of 3 over 2 and positive 1/2. But there's also a point down here in the third quadrant where both of those angles are going to be negative, or both of those points are going to be negative. And then finally, there's another one in the fourth quadrant where the x value is positive and the y value is negative. So that's what we mean by a reference angle. If I give you a measure of 60 degrees, there's going to be 4 points on the unit circle that are going to correspond to that. The absolute value of x and y are going to be the same for each. You just need to go around and change the signs. Okay. All right, the next section deals with angles that may not be on your unit circle. So for example, in the first one here, I'm asking you to find the sine of 15 degrees. Well, 15 degrees is not one of the measures that's on your unit circle. So you can't use the unit circle to evaluate it. But that doesn't mean that it doesn't exist. So in this case, you're going to want to go back and use your calculator. Let me adjust my screen here so you can see. The only thing you have to be careful of when you're using your calculator is the mode that you're in. Okay, so you'll notice that some angles are in degrees and some angles are in radians. So anything with a pi means that you're dealing with radians, and anything that has a degree symbol obviously means that you're dealing with degrees. So if I want to evaluate the sine of 15 degrees, I need to go to my calculator's mode. And if you look at the third line, that's where you switch between radians and degrees. So I'm going to switch it to degrees. And now I can actually evaluate the sine of 15. So I'm going to take the sine of 15 degrees. I don't have to worry about putting in a degree symbol. And the sine of 15 degrees is just going to be 0.25. I'm going to round that to a 9. If I want to deal with the cosine of 2 pi over 3, I'm going to have to go back into my mode and change it to radians. And now I'm going to take the cosine. Now I do want to make sure that I include the pi, and I don't want to type it in as 3.14. There's actually a pi symbol below the clear button. So I'm actually going to type in 2 and then hit second, and that's the caret, divided by 3. And that'll evaluate the cosine for me. And that's just going to be negative 0.5 or negative 1/2. And 2 pi over 3 is actually one of the angles on the unit circle. So I can go back and check for a sec. So 2 pi over 3 is this angle right here. And the cosine, that's going to correspond to the x value, is in fact negative 1/2. So our calculator can also evaluate, excuse me, can also evaluate these functions. Excuse me. most of the time, if it's on the unit circle, I'm going to want you to evaluate using the unit circle. But on the occasions when it's not, you can just go ahead and use your calculator. So in number 3, this is also written in radians. So I'm going to go ahead and take the tangent of negative pi over 4. And it's negative 1. And the nice thing about using your calculator is you don't have to worry about fixing the angle. So if I have the sine of negative 150, the only thing I have to do is make sure that I'm in degrees again. And it doesn't matter that it's negative. The calculator knows where negative 150 degrees is. You do want to make sure you type it in there, though. That's going to also give me negative 0.5. The cosine of pi, that means I have to change it back into radians. Now I can do cosine of pi, negative 1. And then the tangent of 360, again, I have to go back into degrees. And I'm going to take the tangent of 360. Oh, I'm sorry, 630. All right. And notice we get an error message. Why is that? Well, first of all, let's figure out what is 630 degrees. Since it's so big, I'm going to have to subtract 360. So 630 minus 360. Let's figure out where we are in the unit circle. Gives me an angle of 270 degrees. Well, 270 degrees, if I've got my unit circle, that's 3/4 of the way. That's right here. The coordinates for this point are 0, negative 1. So if I'm trying to calculate the tangent by hand, I would take my y coordinate over my x coordinate, and I'd have negative 1 divided by 0. But if I try to take negative 1 and divide it by 0 on my calculator, I get an error message. Because I cannot divide by 0. If I have $5 and I want to divide it by 0, that means I'm making $5 disappear. And I can't do that. Well, I could, but technically you can't. All right, it's undefined. Okay, so you want to make sure that anytime you have a 0 in your denominator, you don't want to write error, you don't want to write imaginary, it is undefined, and that is the word you need to use anytime you divide by 0. That is not the same as if I wanted to find the cotangent of 270 degrees. Because the cotangent would be x over y, or 0 over negative 1. And I am allowed to have 0 in the numerator. So 0 divided by negative 1 is just 0. If I have nothing and I split it up 5 ways, no one's getting anything. So we're allowed to have 0 in the numerator of a fraction, but not in the denominator. And so when you end up with a 0 in the denominator, you want to make sure that you use the word undefined. It's not imaginary, it's not error, it doesn't mean no solution. You're going to use the word undefined, and that is important to do. All right, so I hope that that was helpful for you. The homework should mimic a lot of the problems that we did in this tutorial. If you have any questions, obviously you can come in for Bulldog Block, but we are going to be having a quiz on this Thursday and Friday, which will be the last days of the marking period. There will not be an opportunity for redo, so make sure that you watch the video carefully. If you want to rewind it, if you have any questions, make sure that you come prepared with those questions to class so I can help you.